Welcome to Prabin's Academy. Last class we studied about electric field and electric field lines. Okay. In this video we will study about electric dipole. Electric dipole. Electric dipole means it is a pair of equal and opposite charges separated by a small distance. Okay, it is a pair of equal and opposite charges separated by a small distance. Consider two small charges minus q and plus q separated by a small distance 2a. Okay, this is an electric dipole. Okay, considering 2 point charges minus q and plus q separated by a small distance 2a. Okay, this is an electric dipole. Example for electric dipole are water, CO2, alcohol, HCl, NH3, etc. Okay. Next point. The direction from minus q to plus q is said to be the axis of the dipole. Next point. The direction from minus q to plus q is said to be the axis of the dipole. Okay. Next subheading, dipole moment. Dipole moment denoted by capital P. Okay, it is the strength of electric dipole. It is the strength of the dipole or electric dipole. There is an equation. Dipole moment is the product of one of the charge and the distance between them. Okay, it is the product of one of the charge and distance between the charges. Okay, then P equal to, take positive q. Okay, then q into distance between the charges is 2a. Then dipole moment P equal to q into 2a. Then direction of dipole moment is along the axis of the dipole. Okay, direction is along the axis of dipole. Next point, unit of dipole moment is coulomb meter. Okay, coulomb meter. Okay, next, applications. First one, torque on a dipole in a uniform electric field. Torque on a dipole in a uniform electric field. Okay, consider a uniform electric field. E. Okay, if we place an electric dipole like this, okay, electric dipole AB, length is 2a. Okay, here the charge is plus q, here the charge is minus q. Okay, here the angle is theta. Then consider an electric dipole AB of dipole moment P in a uniform electric field. Let dipole makes angle theta with electric field. Then consider the force on charge plus q and minus q. Okay, the force on this plus q is F is equal to QE, that is in this direction. Okay, that is along the electric field direction. Also, the force on charge minus q is minus QE, and that is opposite to electric field. Okay, so the force is in this direction. Okay, force on charge plus q at A is F equal to QE, that is along the direction of electric field. Okay, similarly, force on charge minus q at B, F is equal to minus QE. Okay, that is opposite to electric field. Then from these two forces, they are equal. Okay, then total force equal to 0, but total net force equal to 0, but the lines of action of above two forces do not coincide. As a result, torque will act. Okay, a torque will act and dipole rotates. Okay, two equal and opposite forces, so net force equal to 0. Then a torque will act because there is equal and opposite forces. Okay, then torque, we know that torque equal to force into lever arm or perpendicular distance. Okay, then we have to construct a perpendicular line. Take this point as C. Okay, lever arm means AC. Okay, we have to find the value of AC. For that, we consider sin theta. Sin theta is equal to opposite side, AC by hypotenuse AB. That is, AB means 2A. Okay, then AC equal to 2A into sin theta. Okay, then torque equal to, one of the force means QE. We can take F is equal to QE into lever arm means 2A sin theta. Okay, that is, we know that Q into 2A equal to dipole moment. Okay, therefore torque tau equal to P, that is Q into 2A E sin theta. Okay, torque equal to PE sin theta, or tau equal to P cross E. Okay, tau equal to P cross E. Cases First one, if theta equal to 0, then torque equal to 0. Okay, second one, if theta equal to 90 degree, then torque equal to PE. That is maximum value. That is maximum value. Okay. If here we are considering uniform electric field. Okay. If the field is not uniform, then both force and torque will act. Okay. If the external force is not uniform, then both force and torque will act. Okay, thank you.